Hello everyone, welcome to my channel Hari Previous Videos, Class 10 Physical Science, Chapter Electricity. So already we discussed some topics regarding to Chapter Electricity. Then today our topic is combination of resistances or resistors. As previous classes or previous sessions, we already discussed what is meant by resistance, then the factors affecting resistance, resistivity, conductivity, all are we discussed. Then today, the combination of resistance, the combination of resistance. So, as we discussed earlier about electric circuit. So, in a electric circuit, the resistors are the components like consumers or bulbs or any electrical appliances. Any electrical appliances are connected in different ways. Connected two ways. One is series connection and other one is a parallel connection. So two types we have connected the resistors in a electric circuit in two ways. One is series, then other one is parallel. Series connection of resistance, parallel connection of resistance. So what is the series connection and what is the parallel connection? The series connection and the parallel connection of resistors. If you want to increase the total resistance of in a circuit, then we need to connect all the resistors in a series. If you want to reduce the total resistance, all the resistors are connected in parallel. So the resistance can be combined two ways. One is series and another one is parallel. So let us understand what is this series connection and parallel connection. So series connection. In case of series connection, the two resistors are joined. For example, this is one resistor. You can consider as R1, and this is the resistor R2. We have two resistors. When the two ends of the resistors, are connected. So imagine that one resistor and this is the another resistor. Two resistors are joined by the ends. So this is three. If ends, when two or more resistors are connected end to end continuously or consecutively, they are said to be in series. So this is the one end and this is the other end. This is the one end, this is the other end. We have two resistors, one is R1 and R2. So one end of the first resistor is connected with the other end of the second resistor. Then similarly, when we connect the third one, like 4, 5. So this type of combination of resistors, of resistances or the resistors is called a series combination or series connection. So what happened if the resistors are connected in series? What about the resultant or the equivalent resistance? equivalent resistance. So let us understand what happened if the resistors are connected in series. So series combination. So the combined resistance of number of the combined resistance or the total resistance or the resultant resistance or the equivalent resistance is increases or we increased or decreased when we are all connected in the series. So we can understand what happened when the series when the resistors are connected in a series. So according to the law of combination of series, the combined resistance or the resultant resistance or equivalent resistance of any number of resistances or resistors connected in series is equal to the sum of all the individual resistance. The total resistance is equal to the sum of all the individual resistance. So the total resistance is called as the combined resistance or the equivalent resistance or the resultant resistance, or simply the sum of individual resistance is equal to their equivalent resistance when the resistors are connected in a series. So REQ, equivalent resistance or the resultant resistance or the combined resistance equal to R1 plus, R2 plus, R3 plus and so on. So the resultant or the equivalent resistance is equal to sum of the individual resistance. So let us derive the equation Req is equal to R1 plus, R2 plus, R3 plus, R4. So equivalent resistance of a series connection. So let us understand how to we calculate the equivalent resistance. See the observe the figure. So there are three resistors are connected end to end. So to a battery, and here we need to calculate the potential difference. So every resistor has a potential difference. If there is no potential difference in the resistor or in an electric conductor, the current cannot flow. So R1 is the resistance of first resistor. V1 is the potential difference of first resistor. R2 is the resistance of second resistor. V2 is the potential difference of second resistor. Then R3 is the resistance of third resistor. V3 is the potential difference of third resistor. Together, the total potential difference happen. As similarly there is final resistance also. Right? So here this is Req. So Req is the resultant resistance and the resultant potential difference. In series connection of resistors, there is only one path. So, in case of series connection, there is only one path of electric current. Only one path of electric current. Hence, the current in the circuit is equal to I. So, I current is passing. So, according to the Ohm's law, according to Ohm's law, according to Ohm's law, according to Ohm's law, potential difference V is equal to IR. Potential difference V is equal to IR. For first resistor, R1, potential difference V1 is equal to IR1. For first resistors, potential difference V1 is equal to IR1. For second resistor, V2 is equal to IR2. For third resistor, V3 is equal to IR2. So as we discussed previously, in case of series connection, same amount and the equal amount of electric current is passed in a circuit. So I is say. So from this we can write V1 is equal to IR1, V2 is equal to IR2, but V3 is equal to IR3. So let Req is the equivalent resistance of combination of resistor in a series. So now let us find out the total potential difference. Total potential difference. Total potential difference V is equal to IR. So from this we can write, so total difference, total potential difference is V1 plus V2 plus V3. Total potential difference is equal to V1 plus V2 plus V3. Substitute V1, V2, V3 in the equation. So for example, it can be taken as this is 1 element and 2, this is equation 3 and this is equation 4. So from equations 1, 2, 3, 4. From the equations 1, 2, 3, 4, V is equal to IR. That's equal to V1 is IR1 plus V2 is IR2 plus V3 is equal to IR3. So here we are calculating the resultant potential difference or the equivalent potential difference. So IR is equal to IR1 plus IR2 plus IR3. IR1 plus IR2 plus IR3. IR1, IR plus IR equivalent. Okay. IR1 plus IR2 plus IR3. So from here you can write all those things, I is the common, current is the same. In a series connection there is only one path of electric current, so current is same. So from this we can do common. So IR is equal to, so here I am writing Req, resultant resultant or equivalent resistance is equal to I is common, then we can write R1 plus R2 plus R3. So V is equal to IR. So here only write REQ. Equivalent resistance or the combined resistance or the total resistance or the resultant resistance. I is equal REQ is equal to I common. So I into R1 plus R2 plus R2. So here I will cancel. Then we can write REQ or resultant resistance or equivalent resistance or total resistance or the combined resistance is equal to R1 plus R2 plus R3. So the resultant or equivalent resistance REQ is equal to the sum of resistance of individual resistance or the individual resistors. REQ is equal to R1 plus R2 plus R3. So REQ is equal to R1 plus R2 plus R3. So three resistors are connected in a series. Here R1 is the resistance of first resistor, V1 is the potential difference, R2 is the second resistance of resistor 2, potential difference is V2, for R3 V3. So calculating equivalent resistance. According to the Ohm's law, potential difference is directly proportional to the applied or the current flowing in the circuit is equal to the potential difference. So V is equal to IR, which should be taken as equation 1. For first resistor, potential difference V1 is equal to IR1. For second resistor, V2 is equal to IR2. For third resistor, V3 is equal to IR3. So the total potential difference, if the current run by the resistor is equal to the current run by the combination of resistors. Combination of resistors is called as equivalent resistor. Equivalent resistance. So equivalent resistance. Equivalent resistance. V is equal to V1 plus V2 plus V3. So the same current I flow through the both resistors in series or three resistors in series. So by applying Ohm's law to the resistor respectively, we will get V is equal to finally V is equal to V1 plus V2 plus V3. So current is same. So for example, here we can write R is equal to V by I. R is equal to V by I. So from this we can write V is equal to IR. Kilogram. So substitute all the one. So finally we get resultant equation R is equal to R1 plus R2 plus R3. R1 plus R2 plus R3. So for example, if R1 is equal to 2 ohms, R2 is equal to 3 ohms, R3 is equal to 4 ohms, then what about the total resistance and the equivalent resistance? REQ is equal to 2 plus 3 plus 4, so 7, 9 volts. So REQ is equal to 9 volts. So the equivalent resistance is more. Equivalent resistance is increases. Equivalent resistance is increases in the circuit when all the resistors are connected in a series. So the combined resistance or the resultant resistance of any number of resistors connected is equal to sum of the individual resistance, and the equivalent resistance of the resistor is greater than or more than resistance of individual resistance. Individual resistance. So 9 ohms is more than resistance of R1, is more than resistance of R2, more than resistance of R3. So when a number of resistors connected in a series to the terminals of the battery, each resistance has the potential different potential difference across its ends. But the total potential difference across the ends, is equal to the voltage of the battery or equal to the potential difference of the battery. So, for example, the total potential difference of the battery is equal to is equal to sum of the potential difference of individual resistor. So V1, V2, V3. So resistor R1 has different potential difference than R2, then R2 is than R3. So three resistors having three different potential differences. But these three potential differences are equal to the potential difference of the battery. For a battery, for example, three resistors are connected. The three resistors are having different potential differences. The sum of the potential difference is equal to the potential difference of the battery which is connected in a circuit. When number of resistors are connected in the series, the same current is passed in the circuit as only one path. So that's why the total potential difference V is equal to V1 plus V2 plus V3. Based on that, we can calculate the total resistance of the resistors. So this is about the series combination or series connection of resistors. So like that, when we number equations, Req is equal to R1 plus R2 plus R3 plus R4 plus R5, like that will come. The equivalent resistance is more than the resistance of individual resistors. In this case, we increase, in this case in the sense, when the resistors are connected in a series combination, the resistance of the circuit, the resistance in the circuit increases. So when we connect the series, when we connect the resistors in series, the resultant resistance is increases. So, but has some disadvantages. So, in our home, if we connect all the electrical appliances in a series connection, has some disadvantages. So, if one electric appliance stop working due to some effect, then all other stop working. Then all other also stop working. So, for example, these all are, imagine that R1, R2, R3 are the three different electrical appliances. Three different electrical appliances are connected in a series. So, if what will happen, if any one of is not working, so what will happen? The remaining other also not working because of there is only one direction of electric current. Only one direction of electric current is there. So just one bulb, for example, 3 bulbs are connected in a series. If one bulb is fused up, then the circuit is breaks, then no electric current is passed in the circuit. Then in a series circuit, all the electrical appliances have only one switch. Only one switch. So we have to use only one switch on and switch off. So have only one switch, with only one switch only we have to use the all electrical appliances. Then the appliances do not get the same voltage. All the electrical appliances do not get the same voltage as the power supply. So in our homes we are using 220 to maximum 240 voltage of electric current. 220 to 240 voltage of electric current. If all the electrical appliances are connected in a series, all the electrical appliances do not get the same voltage of current because of each electrical appliances has a different potential difference. So as per the Ohm's law, amount of electric current passing electrical appliance or in a conductor depends on the potential difference. So all electrical appliances do not get the same voltage. Then overall resistance of the circuit increases too much due to current from the power supply. The total resistance increases. The total resistance increases because of same current flows through a series current circuit, due to which all the appliances of different power ratings cannot draw sufficient current. So these are some disadvantages of series connection. So the next class we will solve some problems regarding to series combination. So I hope understood. So everything wrote on the board. So practice the derivation of equation, very simple one. And the series combination, what is series combination is very important, and observe that what happened to the equivalent resistance, and the circuit diagram is very important, and that derivation is the one of the important concept in the chapter electricity.